The second section of 6.1 is about finding the number of solutions. Before we get started, there are some definitions that I want you to make sure that you've written down. Inconsistent means that a system will have no solutions. So we will look at the graph for that so you can see what that looks like. Consistent independent means that there will be one solution that the system has. And consistent dependent means there are infinitely many. So make sure that you have wrote those down on your note packet. If you need to pause the video, if I'm going too fast, please do so. That way you can write those down. In the next box, it's showing you the graphs so that you can match which one goes with which. So if I have one solution, in the graph it's showing you that it's going to intersect one time. So however many times I intersect will be how many solutions I have. So if you want to fill in the blanks down here, it's saying that the lines will intersect, and then that means the lines will also have different slopes so that they intersect. No solution is going to show you that you have parallel lines after you graph because they never intersect. So that means that we have no solution. So to fill in the blanks, I would put the lines are parallel and the lines have the same slope but different y-intercepts. And then last, if I have infinitely many solutions, you end up drawing one line, but it's really two lines, one on top of the other. So it's intersecting infinitely many times. So in the blanks down there, it says the lines are the same, and the lines will have the same slopes and the same y-intercepts. So three different systems that we're going to talk about: one solutions, no solutions, and infinitely many. So what you're going to have to do is you will have to graph a system and determine how many solutions there are. So if I look at this system, I see that they're in slope-intercept form. So I would graph the y-intercept at 1, right here, and then I would graph the slope up 2 over 1. And I would do that many times so that I can see where they intersect at. Then I would also do the other one. The other one has a y-intercept at -3, so I would go to -3 on the y-axis, and I would go up 2 over 1. Notice that these end up being parallel lines, so that's why this would have no solution for my answer. Let's take a look at another example. On the next example, we end up having standard form for our system. So before we get started, we would have to do the cover-up method to find what it would be. So if I covered up the top one, I would be left with x equals -3. So I could put a point at -3 on the x-axis. Then I would need to cover up the x to find the y. So then I would have 3y equaling -3. I would have to divide by 3 and I would get a y-intercept of -1. Then I'm going to also do the bottom one as well. So I cover up and I get 3x equaling -9. After I solve, I divided by 3. I also got x equals -3. So I ended up with the same x-intercept. Then I need to find the y-intercept. So I got 9y equals -9. I divided by 9. And again, I got y-intercept of -1. This is the same line for both of those equations. So that means we would have infinitely many solutions. Alright, I want you to pause the video and try example number 3. On example number 3, again it's in standard form. So I would have to do cover-up method to find it. So if I cover it up, I would get x equaling -15. So on my x-axis, I would have to go to -15. My graph doesn't quite go there, so I just extend it out so that I could get to -15. Then for my y-intercept, I covered up and I got -3y equals -15. I would have to divide by -3 so that my y-intercept's +5. So then I went ahead and graphed at +5. Now I'm going to do the bottom equation. When I cover up, I get -2x equals 18. Divide by -2, I end up with -9. So my x-intercept goes at -9. Then I'm going to cover up to do the y-intercept. So I have 3y equals 18. Divided by 3 puts me at y equals 6. This particular system looks like it intersects at one point, so that's why we would answer with just one solution. The last one I put on here just to remind you how to graph these. X equals 2, if you remember, is going to be a vertical line that comes through the x-axis at 2, so all of my points will line up this direction. We actually did a table to find this, so if you needed to, you could fill in the 2's with the x's and then put in whatever numbers you wanted for the y's to plot those. The y equals -3 is going to go the other direction. I'm going to be on the y-axis at -3. So if I made a table, all of my y's would be at -3, and then I would fill in my x's. So my points would line up over here. So this system intersects at one point, so that's why we would write down it as one solution. So these will switch in form, so you got to pay attention if it's slope-intercept or if it's standard or if it ends up being horizontal or vertical. And then just determine how many solutions there are by how many intersections occur.